Hello friends, in our last lectures for the chapter Laws of Motion, we have discussed about the fundamental forces in nature, we have discussed about the type of forces, we have discussed about collisions, the types of collisions, and in the last lecture we have discussed about the impulse of a force. Now, in today's lecture, we are going to discuss about torque. Now, what is a torque? Torque is a rotational analog of force, or it is also called as moment of force. This is a new physical quantity which I am going to introduce to you. Now, we know what is a force. According to the Newton's laws, when I apply a force to some body, the body moves from one point to other. So that is for the motion of a body, or to be more precise, for the straight line motion of a body, what is required? A force is required. And what happens with the help of force? The body is accelerated. Force is equal to mass into acceleration according to the Newton's second law of motion. So the body is accelerated in the direction of the force in which I am applying the force. So the body is accelerated in the direction of the force. Now, the rotational analog of force is torque. That is, with the help of force, we cannot rotate the body. The body moves in a straight line. But when we apply torque, the body rotates. Now, what is a torque? What is the rotational analog of force? Or whatever is the meaning of the force in linear motion, the same is the meaning in rotational, same is the meaning of torque in the rotational motion. जो अर्थ फोर्सला स्ट्रेट लाईन मोशन, लिनियर मोशन, ट्रान्सलेशनल मोशनमध्ये आहे, तोच अर्थ टॉर्कला रोटेशनल मोशनमध्ये आहे. म्हणजे एखाद्या बॉडीला जर स्ट्रेट लाईनमध्ये मूव्ह करायचं असेल तर आपल्याला फोर्स अप्लाय करायला लागतो, पण एखाद्या बॉडीला जर रोटेट करायचं असेल तर आपल्याला टॉर्क अप्लाय करायला लागतो. सो टू एक्सप्लेन टॉर्क, I would be taking the example of a door. एका दाराचं एक्झाम्पल मी इथे घेतलेलं आहे. हे एक दार आहे, इथे हे त्याचे हिंजेस आहेत आणि ही ती ॲक्सिस आहे अबाउट विच द डोर विल बी रोटेटिंग. दार उघडतं आणि बंद होतं अबाउट दिस ॲक्सिस ऑफ रोटेशन. तर ह्या हिंजेसच्या मधून जी ॲक्सिस पास होते अबाउट दॅट, तिथे ही रोटेशनल मोशन घडते आहे. आपल्या दाराचं जे हँडल आहे ते हँडल इथे आहे ॲट दिस पॉईंट. नाव, have you ever thought why the handle is at the end opposite to the hinges? हिंजेसच्या बरोबर विरुद्ध हँडल का असतं? आपण इथे जर हँडल लावून बघितलं किंवा आपण या पॉईंटवर हँडल लावून बघितलं असं तर आपल्याला काय अनुभव येतो? किंवा आपण दार उघडं असेल आणि आपल्याला ते बंद करायचं आहे किंवा ढकलायचं आहे, तर आपण या पॉईंटपासून त्याला ढकललं किंवा तर आपला जेवढा फोर्स लागतो F1, तेच जर आपण हा पॉईंट यूज केला आणि दार ढकललं आतमध्ये आणि जो फोर्स लागतो F2 आणि हे जे हँडल दिलेलं आहे या पॉईंटवर फोर्स अप्लाय केला आणि आपण दार ढकललं F3, तर आपल्याला असा अनुभव येतो की F1 इज व्हेरी मच ग्रेटर दॅन F2. ऑल्सो F2 इज व्हेरी मच ग्रेटर दॅन F3. म्हणजे हे दार रोटेट करण्यासाठी, दार ढकलण्यासाठी, दार बंद करण्यासाठी जास्तीत जास्त फोर्स कुठे अप्लाय करावा लागतो? नियर द हिंजेस. आणि कमीत कमी फोर्स कुठे अप्लाय करायला लागतो? अपोजिट, जेवढं लांब हिंजेसपासून जेवढं जास्त डिस्टन्सवर हँडल असेल तिथे आपल्याला फोर्स कमीत कमी अप्लाय करायला लागतो. अँड दिस इज द रिझन वाय द हँडल्स आर ऑलवेज ॲट अ लार्ज डिस्टन्स फ्रॉम द हिंजेस, at the opposite of the hinges. So the rotational ability, force आपण अप्लाय करणार आहे, पण फोर्स अप्लाय करण्यासाठी, फोर्स कशासाठी अप्लाय करणार आहे तर आपल्याला रोटेशनल मोशन घडवून आणायची आहे. सो दिस रोटेशनल अॅनालॉग ऑफ फोर्स और दिस ॲबिलिटी ऑफ द फोर्स टू रोटेट इज कॉल्ड ॲज द मोमेंट ऑफ फोर्स or the rotational analog of force or torque. Now, on what does this torque depend? Torque depends upon mass. First of all, it depends upon mass. आता हे दार जर लोखंडाचं दार आहे, हेवी मेटलचं दार आहे, तर याला उघडण्यासाठी आणि बंद करण्यासाठी मला जास्त फोर्स अप्लाय करायला लागणार आहे. सो इट डिपेंड्स अपॉन टॉर्क. फर्स्ट, ओके, नॉट ओनली ऑन द टॉर्क, इट ऑल्सो डिपेंड्स अपॉन द पॉईंट ऑफ ॲप्लिकेशन. मी फोर्स दार उघडण्यासाठी किंवा दार बंद करण्यासाठी मी फोर्स कुठे अप्लाय करते. विथ रिस्पेक्ट टू द हिंजेस, it is at what distance from the hinges, R1 or R2 or R3. So it depends upon R1, R2 and R3. Now, also it depends, so we can say it depends upon the point of application of the force. मी फोर्स अप्लाय कुठे करते त्याच्यावर डिपेंडेंट आहे की मला किती फोर्स लागणार आहे ते डोर ओपन किंवा क्लोज करायला. Or it also depends on the angle between the direction of force and the line joining the point of application and the axis of rotation. So angle कोणता, कोणामधला angle between the direction of force. Force मी कुठे अप्लाय करते, असा अप्लाय करते. So angle between the direction of force and line joining. Line कुठे join होतोय, point of application. पॉइंट ऑफ ॲप्लिकेशन कुठे आहे, हा पॉइंट आहे, अँड द ॲक्सिस ऑफ रोटेशन. सो ही ॲक्सिस ऑफ, दिस इज द ॲक्सिस ऑफ रोटेशन, दिस इज द पॉइंट ऑफ ॲप्लिकेशन. सो लाईन जॉईनिंग द पॉइंट ऑफ ॲप्लिकेशन अँड द ॲक्सिस ऑफ रोटेशन. सो इट ऑल्सो डिपेंड्स. सो ऑन दीज फॅक्टर्स द टॉर्क, that is the moment of force, depends. And it can be mathematically, this torque is represented mathematically by the symbol tau, by the Greek letter tau. So tau is equal to R cross F. F is the force applied and R is the distance from the axis of rotation. So this is the mathematical formula for the torque. We are considering a rigid body here. The O is the point through which the axis of rotation is passing. So this AOB is the axis of rotation. The body, this rigid body, will rotate about this axis of rotation in this way, which is passing through the point O. Now, supposing, so we will consider the case 1, where I am applying the force. Now, this is the axis about which the body will rotate. It is the same rigid body. I apply force in this direction. So, I apply force in this direction. So, naturally, the force F is seen here, which is applied in this direction, and the line joining the point of application and the axis of rotation. So this is the line joining the point of application of the force and the axis of rotation. It is this line, and the vector we represent as R. Now, as we know, for finding the torque, the mathematical expression is tau is equal to R cross F. Now here we would be discussing two cases for finding the direction of the torque. Now here the direction of the torque is given or found out with the help of the right hand thumb rule. So this is my right hand and this is my thumb. So I am curling my fingers and my thumb is outstretched. So with the help of right hand thumb rule, we would be finding the direction of the torque. So we will discuss the case 1 first. Now here, in this case, the force F, this is the rigid body and the axis of rotation is here. So this is the axis of rotation, this is and the force is applied in this direction. So this is F, and R, which is a vector which is joining the line of the axis of rotation to the line of action of the force, is this. So now R cross F, I apply right hand thumb rule for finding the direction of the torque. So R is in this direction, R cross F. So R is in this direction and F is in this direction. So I curl these fingers from the direction of R to the direction of F. And when I curl, my thumb is outstretched in this direction. So this is the direction So here, this is the direction of the outstretched thumb. That is, the direction of the torque is from the plane of the board. It is outwards. It is coming perpendicularly outwards from the plane of the board. So this is the direction according to the right hand thumb rule. So this is the direction of R cross F when the body is moving in the anti-clockwise sense. Now here it is shown that it is a circle and a dot inside the circle. So circle and a dot inside the circle. Why this symbol is shown? Now this is an arrow. This is the arrowhead and this is the feathers of the arrow here. Now when the arrow is coming outside the plane of the board, coming outside, what will I see? I will see its arrowhead. So I will see this point. So this point is shown here. Hence, this symbol shows that the direction is perpendicular to the plane of the paper and it is outwards. So here the direction of the torque R cross F is perpendicular to the plane of the board and coming outwards. Now, in the next case, we are going to discuss the direction of the torque. Again, which we would be using the right hand thumb rule. Now, again here, the direction, now here the body is moving in a clockwise sense. So, the direction of force is in this way. This is the direction of the force and the direction of R, that is the line joining the axis of rotation to the point where the force is applied. It is this. Now, the body is rotating in the clockwise sense. We know that tau is equal to R cross F and the direction is given by the right hand thumb rule. So, this is R. The direction of R is this. So, R cross F. So, R cross F, I curl my fingers along from R to F in this way. So, my thumb which will be outstretched will go inside the plane of the board. So, here it is shown here that it is shown by a circle and cross inside the circle. That is, the direction of the torque is perpendicular to the plane of the board and moving and going inside. Now, why this is the sign? That is, now when this arrow is moving inside the plane of the board, then we can see the feathers, and hence to show the feathers or to show that the arrow is perpendicular to the plane of the board and going inside the board, and to show the feathers, we are showing this circle and a cross inside the circle. That is, the torque is perpendicular to the plane of the board and it is moving inside the board. The direction is inside the board. So, in this way, with the help of the right hand thumb rule, we find the direction of the torque when the body is rotating in the clockwise or the anti-clockwise sense. Now, the direction of the torque we know can be found by the right hand thumb rule. But how do we find the magnitude of the torque? So, according to the formula or the mathematical representation, tau is equal to R cross F. We expand this cross product. We know that when we expand, we get tau is equal to R into F. Now, we are taking only the magnitude of the torque. So, tau is equal to R into F into sine theta. तुम्हाला in the vector product, this is the vector product. So according to the vector product, tau is equal to R into F into sine theta, which we have discussed in the chapter mathematical methods and the scalars and vectors. So R into F into sine theta. Now here, theta is the smaller angle between R and F. Now, we would be studying three cases. In case 1, R is perpendicular to F. R is the vector which is joining the axis of rotation to the point where the force is applied, and F is the force. So if R and F are perpendicular to each other, so theta will be 90. So tau is equal to R into F into sine 90. But sine 90 is equal to 1. So tau is equal. So this is R into F, because the value 1 is the maximum value for the sine of any angle. So this is the maximum value. So tau is equal to, so this torque is the maximum torque, which is equal to Rf. So when the R and F are perpendicular to each other, the torque is maximum. Now in the case 2, when R is parallel to F, that is the angle between R and F is 0, then we know that tau is R into F into sine 0, but we know sine 0 is equal to 0. So tau is equal to 0. So if the R and F, the directions of R and F are parallel to each other, then no torque is applied. And here, in the third case, if R and F are anti-parallel, that is if theta is equal to 180, they are in the opposite directions, then tau is R into F into sine of 180, but sine of 180 is 0. So tau is equal to 0. So in both cases, the torque is never applied if R directions of R and F are parallel or anti-parallel, and torque is maximum when R and F are perpendicular to each other. Now we know the formula for torque is R into F into sine of theta. So the torque not only depends upon the R, it not only depends upon F, but it also depends upon theta. So it will depend upon this angle also, the directions of R and F, the angle sine theta for the same force, but different angles, the torque will be different. So we can say same force can have different torque as according to the point of application. The next point which we are going to discuss is a couple. We know couple meaning two. So you must have you must have turned handle of your bicycle or the steering wheel of the car when it is turned, or you must have opened the lid of a bottle, or you must have opened a tap. तुम्ही नळ जेव्हा उघडता, you must have opened the tap. At that time, when you open the tap, what do? You apply two forces by these two fingers. One force in this direction and one force in this direction. तुम्ही जेव्हा नळ उघडता त्यावेळेला तुम्ही दोन फोर्सेस अप्लाय करता. एक फोर्स या डायरेक्शनमध्ये आणि एक फोर्स या डायरेक्शनमध्ये. हे कपल ऑफ फोर्सेस तुम्ही अप्लाय करता. The couple of forces which are applied by you, but these two forces are in opposite direction. One force is in this direction and another force is in this direction. They are in opposite direction and along different lines of action. So two forces of equal magnitude but in opposite direction and acting along different lines of action. One direction of lines of action is one force is like this and another force is like this. So such two forces form a couple. Now we discuss about the moment of couple or a torque. Discuss the moment of couple or torque. So here we are seeing two forces. One is the force F1 which is in this direction and another is the force F2 which is in this direction. These two, the directions of the two force are opposite. The magnitude may be same
or maybe not.
The two forces are acting along two different lines of action. Force F1 is here and F2 is here. The position vector of any point on the line of action of force F1 from the line of action of force F2 is R12. And the position vector of any point on the line of action of force F2 from the line of action of force F1 is R21. Now, as can be seen here, the distance between the two forces, the perpendicular distance between the two forces is r. Alpha is the angle. As we can see, r, this is r12. So r1, according to the geometry, we know that what is the sine of an angle? It is the sine of theta is the opposite side upon hypotenuse. So here we can see that this r12, this r12 sine alpha is r, also r21 sine beta will also be r according to the trigonometry. Now here we have that the moment, according to the formula, we have tau, the torque or the moment of couple is r12 cross f1 or r21 cross f2. Now tau, if we take the magnitude only, then we get here tau is r12 into f1 into sine of alpha and r21 into f2 into sine of beta. Now if both the forces are the same, so F1 is equal to F. So let this be equation 1, and if the two forces are same, then both are F. So let this be equation 2. Now we know according to the geometry that R12 sine alpha and R21 sine of beta is R. That is this distance. So from 1, 2 and 3 we get tau, that is torque is R into F. The moment of the couple or torque due to a couple. Now this torque is due to a couple of forces. Many a times we just say the torque when two forces are used. So that is the moment of a couple or torque due to a couple. But in general we say torque, or we can say torque. So, but this torque is, the torques are due to a force and torque is also due to a couple of force. So, this torque we are discussing due to couple of forces, that is two forces F1 and F2. So, now this torque is a constant quantity because it is R into F. Now, it is independent of the point of application, but it depends upon F, that is the force or the two forces, and it depends upon R, that is the separation between the line of action of the forces. Also, the direction of the moment of couple or the torque is given by the right hand thumb rule. So this was the discussion about moment of force and moment of couple, that is torque. Thank you.